Hello, yes class. Good evening. Is this audible to all of you?
Yes, teacher.
So Atif, Fatima, Hamza, Hiba, Sarah and Zain have joined already. So yes, did you all revise it? We had completed optical instruments in the last class. Yes, Atif. Yes, Atif, are you there in the class? Atif Ahmed?
Yes, ma'am, record.
Yes, Atif. Yes, Atif, did you revise? In the last class we had covered optical instruments. So we had started firstly with simple microscope. So two cases were there. What were the two cases that we consider? Two cases we had seen for every instrument. What were the two cases? I'm just asking you the name of the two cases.
When the object was beyond, no, when the image was formed at infinity.
That is one case, and the other one? Yes, Atif, the other one?
Other one, was it?
When image was at?
Was it least distance of distinction?
Distinction, yes, correct. Two cases we had seen when, firstly we had seen when the image was at least distance of distinct vision. Another case we had seen when the image was formed at infinity. Fatima, what is the least distance of distinct vision for human eye?
25 centimeter.
25 centimeter. So at distance of 25 centimeter, we are able to see clearly an object, and at a distance of infinity, we are able to clearly see an object. All right. Yes, Hamza. So what was the magnification for simple microscope in case of least distance of distinct vision? Two cases we had seen magnification as well. Yes, Hamza. Magnification in case of least distance of distinct vision. Least distance of distinct vision. Okay, Hamza. And Hiba, at infinity? Yes, Hiba, at infinity. Josefa, when image is formed at infinity, what is the magnification for simple microscope? Okay, Hibba has also answered. Okay, Hibba. Josefa, are you answering the same part? Okay, we had seen magnification was the ratio of two quantities, two angles basically. So yes, Kulsum, were you present in the last classes? Kulsum, you were there, no? Yes, what is beta over here? M is equal to beta by alpha. What is beta? What is alpha? Yes, Kulsum? Sarah?
Ma'am, could you repeat the question?
What is magnification? Magnification is the ratio of two angles. One we write it as beta, in the denominator we write it as alpha. So what is beta, I'm asking you? The quantity, the angle that we write in the numerator. Yes, Zen. Zen was present in the last classes. Zen, can you answer? For simple, no, I'm on simple only. I have not jumped into compound microscope. For simple microscope, I'm asking. Fatima, can you answer? Fatima?
Yeah, alpha is the angle subtended by the object and the eye, and beta is the angle subtended by the
Final image on the eye.
image.
On the
Yeah, image and the eye.
Okay. Okay, good. AB by BO, no, Sarah, you cannot answer like this. What is AB? What is BO? That is in a triangle that you had considered. Class, revise this. See, simple microscope. We had seen two cases. These two cases we have discussed this. We have an image is formed at least distance of distinct vision. Magnification is d by f plus 1. And when image is formed at infinity, magnification is only d by f. All right. Now magnification in this case, this magnification that we are referring, this magnification is basically beta by alpha. Beta is what? Beta is the angle that is subtended. See, this is beta by the image on the eye. And alpha, this is the angle subtended by the object on the human. So this is the definition. And see why we just did a revision for simple one, because rest of the things are same for compound microscope. See, alpha's definition remain the same, beta's definition remain the same. It's just that in case of your magnification, formulas become a little different. You have this component minus V naught by U naught getting multiplied. Minus V naught by U naught d by Fe plus 1 gives you magnification when image is formed at least distance of distinct vision. I'll write this. C class. Quick revision, be alert and try to revise here, because otherwise I'll ask you at the end of the class. For simple microscope, you had seen two cases. When image was formed at least distance of distinct vision and when image was formed at infinity. These were the two cases. Like this, you have to revise. For this case, magnification will always remain beta by alpha. That is the definition. But what is the final answer? Final answer is d by f plus 1. All right. For this, magnification is only d by f. Then you have compound microscope. For compound microscope also you have same cases. Image formed at least distance of distinct vision and when the image is formed at infinity. Both the same cases. Now do one thing. Just multiply minus V naught by U naught in front of this. D by F plus 1. This becomes E. Same thing. Just multiply minus V naught by U naught and write this as it is and make this Fe like this. This is the basic thing that you have to remember. Rest of the things we had discussed it already. When length of tube is given, how length of tube gets replaces your image distance. All right. This is the summary of what we had studied in the last class. We had done the derivation of each of these. If you want to take a screenshot, take a screenshot of this. This is just a summary of what we have studied. I can ask you any of these. So remember this. At least the formula you all should remember. Derivation you can study later on. But remember the formula for this. I had already announced that I am going to take a test this week. Okay, let's solve a numerical on compound microscope. We didn't do any numerical on this. It says you are given two converging lens of focal length 1.25 centimeters and 5 centimeters to design a compound microscope. So we had studied in case of compound microscope, two types of lens are required. A single lens won't work. So it says find angular magnification if final image is formed at least distance of distinct vision. And second part says when final image is formed at infinity. So see, object distance is how much? You are given two converging lens of focal length 1.25 centimeter and 5 centimeter to design a microscope. So if this is given, this means this is your 5 centimeter is what? This is your object distance. This is your object distance, 5 centimeter. So object distance is given as 5 centimeters to you. Object distance is given as 5 centimeters. Then it says angular magnification. See, let's write the formula of angular magnification first. Minus V naught by U naught D by FE. This is for the infinity one. Second part, image is formed at infinity, because you just have to add 1 for the first part. No, let's do the first part only first. That's 1. This is the first part. Now rest of the things. See, least distinct or distance of distinct vision. Apart from Fatima, Sarah, what is least distance of distinct vision for human eyes?
25 centimeter.
25 centimeters. This is 25 centimeters. Should I write minus or plus, Sarah?
Minus.
Nothing. See, I have told you, in these final formulas of magnification, you don't need to mention anything, because here already sign convention is used in the derivation of the formula. So you don't use sign convention. If you have not mentioned it anywhere in the last class, I think I have written it all over the screen. But by chance, if you all have not mentioned it, do write it as a note in your notebook. Otherwise, if you write minus, your answer will be different from what is the actual answer. So do not use sign convention here. If lens formula is required, any other formula, lens maker formula, then use it. So D is 25 centimeter. Focal length of this is given. Second focus is what? Second focus is 5 centimeters, right? This is the second focus. First focus is for object. Second focus is for eye. So this is 5 centimeters. What all things are required? Yes, object distance is mentioned to you. This is object distance mentioned to you in the question. I had not written it together. So this becomes 5 centimeters. All right. V naught is not given to you. V naught is not mentioned. See, F naught is mentioned to us, and we have U naught. This is object distance, and we have the focal length of objective. If you have F naught, if you have U naught, do you have any method by which you can calculate V naught?
1 by F is equal to 1 by V minus 1 by U.
Yes, sir. Perfect. 1 by F is equal to 1 by V minus 1 by U. That is the lens formula. Using lens formula, you have to calculate. See, if you use lens formula, it will be 1 by F naught is equal to 1 by V naught minus 1 by U naught. So 1 by F. Now, this at this point, you have to use sign convention, because Lenz law does not allow you to exclude sign convention. At this point, you have to mention the sign conventions. So F naught will remain 1.25 only, but object distance will be negative. So this is 1.25 is equal to 1 by V naught minus 1 by minus 5. So 1 by V naught. This gets added. 1 by V naught will be 1 by 1.25 minus 1 by 5 you can write if you just interchange the signs. Or you can simply write 1 by V naught is equal to 4 minus 1 by 5, which is 3 by 5. So V naught will be 5 by 3 meters. Centimeters, everything is given in centimeters, no? So this is in centimeters. Now you have 5 by 3 as V naught. So I think everything is mentioned now. V naught is given to you as 5 by 3 centimeters. So in magnifications formula, put it minus 5 by 3, U is 5, D 25, FE 5 plus 1. This gets cancelled. This is 5. So how much is left? 5 plus 1, this is 6. Right? So 6 by 3, that gives you minus 2. This will be your answer for this. Correct. If it is for the second part, I think just 1 will not be here. So that will be minus 5 by 3. All right, just note it down. Check the calculations as I've done it orally. So there might be some error. Let me know if there is any error. Write down this question, then we'll start a new topic. We are almost towards the end of lesson. So not today, but on Thursday, I'll take a test then. Thursday is Thursday, fine, or next Tuesday? When do you all want to give the test of ray optics? Complete lesson. Though I had announced in the last class that I'll take a test this week only. But let me know, because this is a very huge lesson. Next Tuesday, no? Okay. Then next Tuesday it is. Next Tuesday is 1st of November. So on 1st of November, you have a test on the whole complete topic, ray optics. That will include reflection also, which you have already given. Okay, class. Now one more topic is left, that is your prism. Before that, I just want to confirm whether you have telescope included in your syllabus this year or not. So right now, I'm not sure about it. If anybody knows, let me know. Accordingly, I'll start telescope. If telescope is there in your syllabus, then after prism on Thursday, I'll complete with telescope. Otherwise, we'll complete with prism today itself. So if you all have any information right now, let me know. Otherwise, I'll confirm later on, because right now I'm not sure about it, whether telescope is included in your board examination or not. For your entrances, it is there, but for your CBSE board examination, I'm not sure about it. So I'll confirm. And if telescope is included in your syllabus under optical instruments, then we'll have, because in last year it was included, for this year I'm not sure. So I'll confirm if it is included, then we'll have the class of telescope on the next, that is Thursday itself. Okay, starting with prism. Prism is not a very big topic, but prism is a very scoring and an interesting topic. Because prism, you have that experiment also in your practicals. If you all have had your practical classes, the calculation of the deviation angle of minimum deviation, you plot a graph using prism. So that activity or that practical that is present is quite easy, and most of the students want to have it. Otherwise, the theory part is also not difficult. You just have to have the idea of what is the basic analysis of a prism. So see, prism is basically what? Prism is a wedge-shaped portion So prism is basically a wedge-shaped portion that is not at all triangle completely. You don't have it as a complete triangle. In actuality, the prism has the triangle part that you see are basically the front and anterior and the posterior parts. Prism is actually like this. These portions, no, these are rectangular. So it's like three rectangular parts are joined together by the triangle part. So it is not complete triangle that we observe for a prism. This is what an actual prism is. Not of so much length. Length is determined. So prism is wedge-shaped portion. Wedge-shaped portion of transparent refracting medium bounded by two plane surfaces inclined to each other at a certain angle. So this angle that is formed, no, this is known as angle of prism. Because this is the part where both the plane surfaces subtend an angle. And these are the refracting surfaces, refracting phases. This phase, this phase. These are the refracting phases. Because we'll not be drawing this complete whenever we'll be drawing the prism. We'll be just using this part. All right, this is known as the refracting edge. So the angle that is formed between both of these, this is known as the angle of prism. Now we'll start with the derivation that is there in the prism. This derivation is very important. This derivation comes a lot in the examination. That is minimum deviation, angle of minimum deviation. So for that now we'll just draw prism first. Angle of minimum deviation. So certain labelings are there. This is the angle of prism A. Let's say this is A. This is the angle of prism. Now this is the phase where ray of light is incident. Let's say ray of light is incident. This is the incident ray. Let's say this is the perpendicular normal. Yes, Zen, what is this angle? This is the incident ray. This is the normal. Yes, Zen. What is this angle called as? Incident angle. Yes, angle of incidence or incidence angle. Good. Now what will happen? Ray will get refracted. At this surface, what will happen? Ray will travel from denser to the rarer medium. And this is the normal. So what will happen? Now it will move away from it. Why it will move away? Why is it moving towards that? We have already discussed for the rarer to denser surface and denser to rarer surfaces. Fine. Hiba, what is this angle that is formed? This is the normal ray. This is the refracted ray. So this angle formed is? Yes, Hiba. Huzaifa Ahmed, what is this angle called as? Anyone else apart from Hiba and Huzaifa?
Refracted angle.
Angle of refraction. Okay. Huzaifa has also answered angle of refraction. What about you, Hiba? See, only Fatima and Huzaifa answered this. See, this is the normal, this is the refracted ray. So this is angle of refraction. Understood or not, Hiba? This is very basic. Otherwise, I'll start taking your Viva in every class and I'll also ask you all to open your cameras and then answer the questions. Fine. Now see, this is one more angle. This is one more angle formed. So let's say this is R2. This is the incident angle at this phase, but we are referring it as R2 because here we have it as R1, right? Now, this is the emergent angle, which you can say angle of refraction for this phase, but let's simply say this is the emergent angle. Now see, if the ray didn't deviate, then what would have been the path of the ray? Let's see. This would have been the path of the incident ray if it would have not deviated. Now, if it is deviated, if it has deviated, now what is the angle? This angle is the deviation. This is the angle of deviation. A ray of light was coming. Now it is moving like this. So this is the angle, no, that is formed. Ray of light is coming. Now it is moving like this. So what is the angle formed? The angle formed is delta, which we are referring. Fine. This is delta. This you can write it as I2 also. If you want to make it I1 and I2 also, R1 and R2. Complete the triangle for the derivation. All right, now we have to derive the angle of minimum deviation using all these things which are present. So angle, this is angle of deviation. Let me write it. This is angle of deviation. Delta is angle of deviation. R1, R2 you can say, R prime you can say, I1, I2 you can say, I1, I prime you can say. All these are fine. Now see, if this is angle of the prism, right? So if you see, look at this triangle, this angle plus this unknown x angle, R1 plus R2 plus this x gives you 180 degree, right? This gives you 180 degree. Also, if you look at this, I think we have to name this something. Let's name this as N, this point, Q, let's name this point as R, and this point is as M. Now see, if you look at this quadrilateral that is formed, AQNR, this quadrilateral AQNR. Now you look at over here, A angle of incidence plus this opposite angles of quadrilateral are what? The sum is 180 degree. So A plus this X is 180 degree. Right. So from here you can say R1 plus R2 is equal to 180 degree minus X. From here you can say angle A is 180 degree minus X. So A is equal to R1 plus R2. First thing, is this clear? Till here, is it clear to all of you?
Teacher, how did angle A come in the quadrilateral?
This is the quadrilateral. I'll draw it here. This is angle A, angle of the prism. This is A. So this is A. This is Q, this is N, this is R. So this must be something we are not aware of. This must be something we are not aware of. We are aware of this X and we are aware of this A. Now is it clear, Fatima?
Yes, teacher.
Okay. So if it's clear till here to all of you, then let's proceed with the derivation. Okay, see. This triangle, no, one more thing here. If you just look in the figure. If you look at this triangle, or this triangle that is formed, MQR, this small triangle that has been formed, this is acting as exterior angle, right? This is acting as an exterior angle delta, or even forget this exterior angle. Just have a look at this MQR. So can't you say delta is actually sum of this angle and this angle? Using your exterior angle property, forget these two right now. Just have a look at these. If you say this is angle 1, let's say this is angle 2. So can you see angle 1 plus angle 2 will give you delta using exterior angle property. So if you use exterior triangle property in triangle MQ, what was that point? R, no? MQR, yes. So if in triangle MQR, delta becomes equal to angle MQR plus angle MRQ, which I have mentioned as angle 1 plus angle 2. This is what is delta. Now, what is angle 1 actually? Angle 1. See, this is angle 1. Now, I'll make you see over here. Look at this carefully. See, class. This is angle of incidence, right? This is what? This is angle of incidence. See, class, this is angle of incidence. It means this complete is what? This is angle of incidence. This is what? Yes, class. This part. What is this? This is angle of incidence. This is what? Look at it. Yes, Atif, how much? Atif.
Yeah, angle of incidence.
Angle of incidence only. No, why?
Vertically opposite. angles.
Vertically opposite. Exactly. Perfect, Atif. See, these are forming vertically opposite angles. Like this also, this and this, both these are same, vertically opposite angles. Now, this angle of incidence, this one, vertically opposite angle, this is made up of what? Angle 1 plus R1. That makes your this complete angle, which is equal to angle of incidence. Similarly, here also your angle 2 plus your angle of refraction, this R2, makes up your emergent, which is equal to this complete because of vertically opposite angles. So see, if you have this case, angle 1 plus angle R, angle 1 plus angle R1 is actually equal to I1. So angle 1 can be written as I1 minus R1. Similarly, angle 2 plus angle R2 can be written as emergent angle. So angle 2 is equal to emergent minus R2. Same things I'll put up here. So deviation, angle 1 is what? 1 is I1 minus R1 plus angle 2 is what? E minus R2. Is it clear till here? Yes or no? Clear or not? Till this point?
Yes, ma'am.
Clear? All right. Now see, I1 minus R1 plus E minus R2. This is what we have. So if you combine all these terms together, if you make this I1 plus E1 plus E, take the minus sign common from this R1, this becomes R1 plus R2. If you take minus sign common from here. Look, from here I've just taken minus sign common. R1 and R2 are here. So E1, I1 plus E was already there. So I have written it separately. Now minus R1 minus R2 was left. From here I have taken minus common and R1 plus R2 is left. R1 plus R2 we have just written was equal to something. A. It was equal to angle of prism. So angle of deviation is what? Angle of deviation is I1 plus E. I1, no need to write I1 if you're writing E plus angle of prism. This is angle of deviation. This is not minimum deviation. This is just angle of deviation.
Minus A, right?
Oh, yes, yes, minus. This is minus, the main formula. And here also you can leave it as I if you're writing E. Now, minimum deviation, if you talk about, specifically if you talk about minimum deviation. Now see, for minimum deviation, your angle of incidence becomes equal to angle of emergence and both the angle of refraction become equal to each other. This is the case. This is the conditions that are present when you are solving. So here, if these are equal, see, delta minimum for minimum deviation. This will become what? Both are same, so it gets twice. See, delta is what? Delta is I plus E minus A. If E is equal to I, you get what? 2I minus A. This is delta minimum. An angle of refraction, if you write. See, angle of refraction also. R1 plus R2 was equal to A. So 2R1 you can say is equal to A. R1 is equal to A divided by 2. So R1 is equal to A divided by 2. Two things you have over here. First thing that you have is delta's value. Delta minimum is 2I minus A. Second condition that you have is R1 is equal to A by 2. Right. This is the condition for minimum angle of deviation. The angle of incidence is what? This is minimum angle of deviation. From here you have angle of incidence, you can take it out. Angle of incidence is what? If you take out angle of incidence from here. Angle of incidence will simply be from here, if you write it down, delta minimum plus A divided by 2, right? From this equation. So you have two equations, first and second, which are required by you. First, tell me, these two equations are clear? How to write these?
Yes.
Clear? Clear? Others also? R is just written, only those equations are used. It's just that R1 is equal to R2 and I is equal to E. Now see, if you use Snell's law, if you apply Snell's law, then your angle of refraction is sine I divided by sine R. So sine of I, what is I? I is delta minimum plus A by 2 divided by sine R is A by 2. Sine A by 2. This is the full formula for angle refractive index also, you can say. From your angle of minimum deviation is calculated. Maximum times angle, this will be given to you. Sometimes n will be given, delta minimum will be asked. Most of the times delta minimum will be given and n will be asked. This is the formula, final formula for it. Now we'll do numericals on this. So first note it down and mark this derivation as important. One of the important topics that you have to revise before you appear for your exam. Angle of minimum deviation. Questions are also there, even in your practical part also it can come. Note it down wherever you're not able to understand, then and there stop me, because this is important. And if you have not understood, then it will become trouble in doing dispersion and rest of the topics that are upcoming.
Ma'am, can you scroll up for a moment? Okay, ma'am. Thank you.
Just before Snell's law, I is equal to, okay, this I part. Look, this we had derived, I is delta is equal to I plus E minus A. Till this, is it clear, Fatima, this part?
Teacher.
Okay, now see, I and E are equal. So instead of this E, I can write I because both are equal. So that becomes I plus I minus A. So delta is 2I minus A. How can I write 2I? 2I will be equal to delta plus A. I will be equal to delta plus A divided by 2. Since this is minimum condition, that's why I'm adding this minimum. Got it?
Yes, teacher.
Okay, see, this says calculate refractive angles of a material of an equilateral prism for which angle of minimum deviation is 60 degree. See, for an equilateral prism, the angle of prism is also 60 degree. Fine. So angle of prism is also 60 degree. What was the formula? N is equal to sine A plus del minimum by 2 divided by sine A by 2. This is the refractive index. So N is unknown, A is 60 degree. This del minimum, angle of deviation minimum, is also 60 degree. C, refractive index angle, N will be equal to sine 60 plus 60 by 2 divided by sine 60 by 2. So N is equal to 60 plus 60 by 2. This is 120 degree divided by 2, that is 60 degree. So sine 60 degree divided by sine 30 degree. Sine 60 degree is root 3 by 2, 30 degree is 1 by 2. So refractive index is root. All right, note it down. We'll do some more questions on this. So this question says a ray of light passes through an equilateral prism such that angle of incidence is equal to angle of emergence. If angle of emergence is 3 by 4 times the angle of the prism, Then you have to calculate the angle of deviation and you have to calculate the refractive index of prism. See, angle of prism is 60 degree. Emergence is 3/4 of A. 3/4. So A is 60. So E will become 3/4 into 60. So this becomes 15 into 3, that is 45 degree. And angle of incidence is equal to angle of emergence. If angle of emergence is 45 degrees, then angle of incidence is also 45 degrees. Angle of the prism is 60. Emergence and I, these are 45 degrees. So first part says angle of deviation. We had seen this formula because this is not angle of minimum deviation. Minimum angle of deviation is not given. For the normal formula of the angle of deviation, we had seen that I plus E minus A was the formula. So this is 45 plus 45 minus 60. Directly 90 minus 60 is equal to 30 degrees. So 30 degrees is what? 30 degrees is the angle of deviation. Now for refraction, angle of refraction, we'll use the minimum deviations formula. Fine. Because this is what we have got now, the angle of deviation. Now using this, we can directly calculate the refractive index of the material. So for using the first part, we have calculated the angle of deviation. Now using this, we'll calculate the minimum angle of deviation. And then we'll use the refractive index for it. So this n is equal to what? For the second part, n is equal to sine a plus del by 2. Here this is del minimum, sine a by 2. Rest of the things were given to us. N is equal to sine 60 plus 30 by 2 divided by sine 60 by 2. So angle of refraction, this n is equal to what? 60 plus 30, this is 90 by 2, that is 45. So sine 45 and sine 60 by 2 is 30 degrees. So sine 45 1 by root 2, sine 30 is 1 by 2. So 2 by root 2, you can even rationalize it by multiplying it by root 2. This gives you n as root 2 only. Fine, note it down. Any doubts you have in these two parts, let me know. One more thing, class. If in the same part, no, this question can be modified in such a way that an extension of this could be calculate.
Teacher, can you scroll up one?
Yes, I'm scrolling it up. I'm telling you one more thing, which is a continuation of this only. If it says calculate speed of light, if it can come as a separate question also in the Prism. So see, you will calculate all the steps same. You will reach this last step, that is n is equal to √2. Then if once you have reached the step, then you can say refractive index. So speed of light divided by speed in any medium. So speed in any medium will be speed of light divided by refractive index, which will be 3 into 10 to the power 8 by √2 meter per second. So this can be a modification. All right, now note it down. So last question you have, calculate value of angle of incidence when a ray of light incident on one face of equilateral prism produces emergent ray which just grazes along the adjacent face. This means what? You have a prism. This is, let's say, A part, angle of incidence, that is A. Now it says what angle of incidence, you have to calculate the angle of incidence. When a ray of light is incident on one face, let's say the ray of light is incident at this face. This is the normal. This is the normal. This is incident ray. So this is angle of incidence. This it gets refracted. This is R1. Then it says it produces an emergent ray which just grazes along the adjacent face. So it will just graze along the adjacent face. It will not be refracted with making angle of certain refraction. It means if this is the normal that is drawn up here, it is grazing the surface and normal is making an angle of 90 degree. So emergence angle also becomes equal to the angle of normal, that is 90 degrees. This is R2. Refractive index of the prism is given in 2. Let's say this point is A, this point is B, because these 2 points are important for us. Now see, if you apply Snell's law at this point, Snell's law at A point. If you apply Snell's law at the A point. Yes, Kulsum, apply Snell's law in at A point. Refractive index is also given, angle of incidence is also there, angle of refraction is also there. At this point, what will be the application of Snell's law? Kulsum. Yes, Kulsum. Fatima, you only answer. Can you try this? Fatima. Yes, Fatima.
Sin 9.
A point. Look at A point. A point. Sin 90 is present here. That is at B point. I'm asking you, look at this A point. I is here, R1 is here, root 2 is here for N. How will you write Snell's law at A point? Fatima. What is the formula of Snell's law?
Sin I by sin R.
Sin I by sin R, this is equal to refractive index. So here the refractive index is root 2. Sin I is here and sin R is R1. Kulsum, your mic is, I think, not working because rest of the time you have answered, I was not able to hear you. So Kulsum, whenever you're answering, write it in the chat column. Because I hope I am audible to you. If I'm audible, just reply me yes in the chat column. Fine, this is angle of incidence from here if you write. See, if you can write and calculate angle of incidence from here. Rest of the things are unknown. If you write, see, sin I will become root 2 into sin R1. I will become sine inverse, and this entire term, that is root 2 sine into R1. So I becomes equal to sine inverse root 2 sine R1. So can I keep this as my final answer? Angle of incidence was required. So I have calculated the angle of incidence at this point A. So fine, clear till here? This is your answer, no? Angle of incidence was asked to you in the question. Calculate value of angle of incidence. So angle of incidence is this. Is it okay to write till here? Do you think the answer is insufficient, or you think yes, right? Angle of incidence was asked, so we have written angle of incidence.
It's insufficient.
Insufficient. Why, Atif? So only Atif has paid attention to this part. Yes, Atif. Anything you see.
We also need to check the Snell's law at B.
Hmm?
You also need to check Snell's law at point B.
Why? Angle of incidence was asked to us. Angle of incidence we have calculated from point A. Why point B? Yes, Fatima. Want to try?
Teacher, because root 2 into sine R1 is equal to sine I.
Root 2 into sine R1 is equal to sine I. Yes, using that only we calculated I know. I am saying angle of incidence was asked to us. So this is angle of incidence. It is insufficient. The answer is not correct. We cannot stop till here. Agreed with you, Atif. That is right. But why? Why do you think this is not the answer? If in your exam you're getting sine i's value this, so I will be sine inverse this much. So what's wrong here? It's angle I. Yes, angle I. Angle of incidence. This was asked to us. This I have written. Yes, then.
We
So
have to substitute root 2.
root 2, no. Why root 2? Root 2 is a proper constant term that is given in the question.
We need to find the value of sine R1.
Sine. Good, Atif. That is correct. Sine R1. See, R1, is there any mention of R1 in the question? This I had written on my own. R1 is the angle. Calculate value of angle of incidence. Root 2 is given. Angle of emergence is given as 90 degree. Angle of incidence was just R1, R2. It had no mention of R1 and R2. So R1, R2 खुद से नहीं लिख सकते ना. You have to write the terms that are given in the question. That's what I was trying to tell you. Even in your exam, if you have any question, you cannot use variables of your own. If you are using the variables, you have to substitute it in terms of whatever is given to you in the question. For sine R1, we'll use Snell's law at point B. Snell's law at point B. So that will become sine. First angle in that is this root 2. You can write root 2 multiplied by the angle that is present is R2. Here the refractive index is 1 for air into sine 90 degree. So sine R2 is what? See, R1 is not. This is still R1. This is still R2. R1 is not given. So this becomes sine 90. This is 1. So 1 by root 2. So R2 becomes what? This is what? 1 by root 2. 45 degree. R2. Now see, R2 plus R1 is equal to angle of the prism only, no? R1 plus R2 is equal to angle of prism. So R1 will be equal to A minus R2. 60 degree minus 45 degree, which is equal to 15 degrees. So now sine R1 we have, it has 50 degree. So your final answer is what? Final answer is sine inverse root 2 sine 15 degrees. Now there is no term that is not mentioned in the question. Fine. Root 2 was already mentioned, so we will not replace root 2. Because if you write the variables of your own, that will not be present in the marking scheme, which the examination is checking. All right, now note it down. Then we'll do some other topic from this only. This is all. I think lots of questions we have practiced, 4 to 5 numericals. If your angle of prism is very small, the angle is very small, then the deviation has another formula that you will use. So deviation through prism So deviation of prism through a small angle. Let's say this angle is A. So again, incident ray will be there. This will be the normal reaction angle of incidence. Deviation will occur. This is R1, R2. This is emergence. This is delta. So delta is equal to I plus E minus A we had seen. See, refractive index of outer is air 1. So if you apply Snell's law at this point, let's say P point. Snell's law at P if you apply. So that becomes 1 into sine I is equal to N2. Let's say this is N2, which is N2 into sine R1. So R1 into sine I is equal to N2 into sine R1. If small angle of approximation is there, no, then sine theta is becomes equal to theta almost. So I will become NR1 only. Similarly, E will become NR2 only. This is the difference that will arise in your derivation. So this is a very short derivation. This derivation comes in your exam. Even the derivation for angle of minimum deviation also comes in your exam. So delta will be I is NR1 plus E is NR2 minus A. So take N common, that becomes R1 plus R2 minus A. So R1 plus R2 is what? R1 plus R2 is A only. This term is A minus A. So delta is A N minus 1. All right, small derivation, just copy it down. If you all have completed, just text me done in the chat column. We have dispersion left. We'll do dispersion, and if telescope is there, then we'll do telescope in the next class. Okay, all those who have completed, you all can leave the meeting. We'll meet on Thursday now. Okay, thank you so much. Goodbye. Take care.
Thank you.
Thank you.